Hi, today I'm going to present about our group assignment, which is automated fruit recognition using computer vision. So this is our group members. The first one is Alif Haronudin Ismail, and second one is Hiang Chuan, and the third one is Moganraj Krishnasamy. So introduction for our assignment is to develop a computer vision system for automated fruit recognition from drone capture images, like to identify the types of fruits. Mission is to create a real-time fruit recognition system using CNN or call as convolution, a neural network, and image segmentation to provide accurate, timely data on fruit types and quantities, enhancing agricultural efficiency and aiding farmers in decision making. So this is our proposed system. For the first one is data set. This is data set of fruit is classified into 5 class of fruit and consists of 10,000 images with various of angle. The second one is pre-processing, training the images in poor classification result due to their varying shapes and size. The images are resized into square that is 64 times 64 pixel and remove unnecessary objects. The third one is to train the model. A batch size of 32 was used. After 30 epochs, the model reaches a satisfactory delicacy. The last one is recognized fruit. The fruit was identified by the system by identifying its type based on the picture path that was specified in the code.
Thank you, Chuan. I will now explain about CNNs and their significance. CNNs, which is known as convolutional neural networks, are a class of deep learning algorithms designed specifically for processing and analyzing visual data. They are particularly effective for image processing and recognition tasks. CNNs consist of multiple layers, which is first convolution layers, second is pooling layers, third is fully connected layers. Convolutional layers detect and analyze features such as edges, textures, and patterns. Pooling layers reduce the dimensionality of the data, helping to manage computational complexity. Fully connected layers combine the features to classify images. CNNs excel at classifying images by detecting and analyzing their features. They can identify and localize multiple objects within an image, making them ideal for recognizing and counting different fruits. This is datasets. Before performing recognition, it's crucial to analyze patterns. Here, datasets serves as patterns for the model to recognize similar or dissimilar patterns. Accurate datasets are essential for effective model training and evaluations. They play a key role in several areas: image classification, object detection, and pattern recognition. Image classification provides labeled images that help the model learn to classify different objects such as fruits correctly. Object detection with annotated images enable the model to learn how to identify and locate objects within an image. Pattern recognition, the variety and diversity in datasets help the model generalize and recognize patterns in new, unseen data. With this theoretical foundation, I will now pass it to Harun, who will demonstrate how our system recognizes and counts fruit using these principles.
Assalamualaikum and good day to everyone. My name is Harun and today I will be showing the demonstration of training the neural network system. So firstly, importing libraries. We import the necessary libraries to the system. Next, with data processing, we load and preprocess the training image from the dataset directory. Here, images are labeled automatically resized to 64 by 64 pixels and grouped into batch of 32. Next is validation image processing. We load and preprocess the validation image similarly but with a batch of 5. Next is building the model. We construct our convolutional neural network model using TensorFlow sequential API. Next, compiling and training the model. We compile the model with an optimizer, loss function and metrics, then train it using the training and validation set. After that, saving the model. We save the trainer model and its training history for future use. Next, calculating accuracy of model on validation set. Next is accuracy visualization of training result. We plot the training accuracy over the epochs to visualize the model's performance during training. And after that, validation accuracy visualization. We plot the validation accuracy over the epochs to visualize the model's performance on the validation data. Next, moving on to testing model. First, we import the necessary libraries such as NumPy, TensorFlow, and Matplotlib. Then we also mount Google Drive. Next, loading the model. This can be done by uploading the pre-trained model that we have done just now, and then upload it to Google Drive and load it in the code. Next, visualization and performing prediction on still image. We can choose any image from the dataset, which is test. We can pick any image and then copy the file path. This is the example of an apple that we are going to predict. Copy path and then replace it at the image path. Remove any unnecessary code and then try running it. Then we load the image and resize it to 64 by 64 pixels, the size expected by the model. We convert the image to an array and then wrap it in an additional array to form batch of size 1. For the prediction, we pass the processed image to the model to get predictions, which are probabilities for each class. We print these probabilities and the maximum probability. As for the output, the image is annotated with its type of fruit class, and then we also use code to revert back from BGR to RGB to represent the original image of the fruit classifier. So this shows apple.
Finally, here we are. In conclusion, our team has successfully developed a robust system for automated fruit recognition using convolutional neural networks and image segmentation. Through the utilization of datasets sourced from Kaggle and Google Colab, we have achieved precise identification and counting in occurred image captured by drones. This project underscores the power of CNS in real-time object detection and highlights their potential to enhance agriculture practices through advanced computer vision techniques. Thank you for your attention. That's all from us.